Since the 90s, vapor recovery stage 2 has been introduced at petrol stations in Europe. With this technology, the customer is exposed to considerably less petrol vapor. In many countries, active vapor recovery with vacuum suction pump has prevailed. A comparison: nozzles without and with vapor recovery. A special infrared camera shows the difference. The nozzle without vapor recovery emits a significant amount of volatile hydrocarbons. On the right side, you see the efficiency of active vapor recovery. Almost no emissions are visible. There are two types of vapor recovery: Stage 1 and Stage 2. Stage 1 describes the closed cycle between refinery and petrol station storage tanks. Stage 2 describes the vapor recovery while fueling motor vehicles. Hydrocarbon vapors are captured by the suction inlet of the nozzle. Within the coaxial hose, the vapor is transported towards the pump. The outer hose provides the fuel. A vacuum pump within the dispenser transports the vapors back to the storage tank. Let's take a closer look at how the nozzle works. When pulling the lever, fuel pressure will open the valve. In the gap between valve seat and poppet, the fuel flow creates a vacuum. To balance this vacuum, air is drawn into the fuel from the spout tip. The fuel rising in the tank opening interrupts the airflow and creates a vacuum. The diaphragm is lifted by the vacuum and causes the shutoff. Fuel and vapor flow stop. The volume of recovered vapor and dispensed fuel have to correspond. Various dispenser types need to be explained. For single product dispensers, use the standard ZVA Slimline 2 GR. The dispenser meter provides an electronic pulse which determines the flow rate of the vacuum pump. Within the nozzle, there is only an insert to split vapor and fuel. For multi-product dispensers with built-in proportional vapor valve, use ZVA Slimline 2 GRV. The meter's electronic pulse controls a proportional vapor valve that's integrated in the dispenser housing. Within the GRV nozzle, there is an on-off vapor valve. It opens automatically with the fuel flow and will close when the nozzle is not in use. For MPD without a built-in proportional vapor valve, use ZVA Slimline 2 GRVP. Within the dispenser, no electronics are necessary to control the vapor flow. The proportional valve within the GRVP nozzle controls the vapor volume by a suspended valve. It is opened and closed according to the fuel flow. Additionally, the GRVP will close the vapor channel when the nozzle is not in use. This diagram shows the emission of volatile organic components is significantly reduced by vapor recovery. ZVA Slimline 2 for vapor recovery is available in 3 versions. GR with a simple vapor insert for single product dispensers, GRV with on-off vapor valve for MPD with built-in proportional valve, and GRVP with vapor proportional valve for MPD without built-in proportional valve. CSB21 is a reusable safety brake protecting dispenser, hose and car against damage from drive-off incidents. The coax hose assembly is an integral part of the Elaflex active vapor recovery system. It consists of a kink-proof inner vapor hose, a highly flexible fuel hose, and special couplings. ZAF coax adapters are used to connect the hose to the dispenser to split vapor and fuel conduit. Elaflex petrol station equipment is reliable, tested, and certified. Hose production is exclusively carried out by Europe's leading rubber specialist ContiTech, Germany. Highly resistant hose liner, flexible braids, long-lasting product marking, abrasion-resistant cover with a smooth surface. Conti's rubber expertise, combined with Elaflex's development, is our strength. Nozzles are manufactured in our own plant in Germany. The factory sets benchmarks regarding quality. State-of-the-art equipment, an efficient workflow, and consistent tests during the production process. These factors ensure that Elaflex makes the difference.